Okay, good morning class. So today we're looking at Euclidean Geometry. It's examples for exercise 2. Exercise 2 is on page 256. Exercise 2 is on page 256. And I'm reading from example. Example on page 255. Okay, so we're looking at theorem 1, the converse. This is not for examination purposes. The theorem, the proof of this theorem is not for examination purposes. The theorem that says we have to prove that we've got A, B, C, D and E. If those lines are parallel, then AB over BC is equal to AD over D. That's the only proof for this one you need to know. So today we're going to look at the converse of this proof. So the converse is basically the reverse. So the reverse is that if you have a triangle and you've got PQR, triangle PQR, and you've got ST here. If we can prove, remember if these lines are parallel, then AB over BC is equal to AD over DB. Okay? So what we're going to look at today is if PS over SQ is equal to PT over TR, which is the reverse of this. No? If that is the case, then ST has to be parallel to QR. Why? Because a line divides triangle PQR in proportion. That would be your reason. Okay, but we'll see it in action now. Alright, so let's see, read what they say here. If a line cuts two sides of a triangle proportionally, then the line is parallel to the third side. Whenever you use this theorem, the reason you must give is line divides side of triangle proportionally. Okay, so that is your reason. Okay, so let's look at the first example. This is example, this is on page 255. Example 5, page 255. So here we are told that in triangle ABC, so this is your triangle ABC, AD is equal to 10, BD is equal to 3 centimeters, AE is 15 centimeters, and EC is 4.5 centimeters. The question says prove that DE is parallel to BC. Okay, so where do we start? Remember, we're going to prove that the ratios are equal. You guys understand? So we don't go straight and say the ratios are equal. Okay? We start off by saying that AD over DB is equal to 10 over 3. Alright. Then we go with AE over EC. So AE is 15 over EC is 4.5. So let's put that in the calculator. So 15 over 4.5 gives us 10 over 3. So what do you notice? It is the same. So we state the obvious, we say since AD over BD is equal to AE over EC equals to 10 over 3. So that is the case. Therefore, DE is parallel to BC. Why is it parallel? Because a line divides triangle ABC in proportion. Or line divides triangle proportionally. You guys understand? So therefore the lines are parallel. Any confusion there? Okay, so let's look at example 2 on the same page. So this is example 6. Okay, so we are told that in triangle ABC, this triangle ABC, and triangle ACD, you've got two triangles. We are told that XY is parallel to BC. Okay, which means now to say that AX over XB is equal to XY over YC. You see that, people? Okay? Then we are told that, and all these variations of course, then we are told that YZ is parallel to CD. If those lines are parallel, what do we know? AZ over ZD is equal to AY over YC. Proportionality theorem. Can you see that? And these variations. We are asked to prove that XZ is parallel to BD. So, if XZ was parallel to BC, to BD, then what could we have concluded? That AX over XB is equal to AZ over ZD. So, in order for us to prove that these lines are parallel, we prove exactly that the ratio is equal. You see that, people? But just coming back to what we have already indicated, we see that this line, since those lines are parallel, so AX over XB is equal to AY over YC. But remember, those lines are parallel, so AZ over ZD is equal to AY over YC. When you say AY over YC, okay, I mean both. Not so, people. So let's just take that again. Because we're working in two different triangles, and there's more than one triangle here, we name the triangle. In the previous sum, it was only one triangle I was working in. Okay, in triangle ABC, in this triangle here, what can we say? We can say that AX over XB is equal to AY over YC. Why? Because of the proportionality theorem, with AXY being parallel to BC. Then we see that in the other triangle, in triangle ACD, this triangle now, we can say that AZ over ZD is equal to AY over YC. Why? Also the proportionality theorem with YZ being parallel to CD. So what do you notice now? That AY over YC is the same in that thing.
Attention all staff and learners, please take note that assembly will take place in period 2.
Okay.
Assembly will take place in period 2.
We're halfway through this lesson. But anyway, what do you notice? It's the same. So we can conclude, therefore, AX over XB is equal to AZ over ZD. Isn't that what we just said now? AX over XB is equal to AZ over ZD. Then these lines are parallel. So we say since that is the case, therefore, what can we conclude? Therefore XZ is parallel to BD. Why? Because a side, or side, divides, or line, sorry, not side, line divides triangle ABD in simple, huh? Right, so with that you should be able to do exercise 2 on page 256. Okay.